So this is problem 7, chapter 20 of Giancoli 6th edition. So we have a force on a wire, and they tell us that this force is maximum when this wire is placed between the pole faces of a magnet. Okay. The current, they say, flows horizontally to the right. So I'm going to put here the current moving to the right. And we have a magnetic field that is vertical, but they don't tell us if this magnetic field is pointing up or down. So I just know that this magnetic field is vertical. Okay, but when we put this wire in this magnetic field vertical, we see the wire jumping towards the observer. Okay, when the current is turned on. So if we know that this wire is going to jump towards the observable, I know that there is a force towards the observer out of the page. Okay, so from this we'll be able to find the direction of this magnetic field, if it is pointing up or down, if the top is south or north. Okay, so what we want to know is this top part, is it north or is it south? Okay, so let's use the right hand rule. I'm going to follow the current. So with my 4 fingers, I'm following the current. The magnetic field, I don't know if it's pointing up or down, but I know that my thumb is coming out. So if my thumb is coming out, from that I will now find out, I now conclude that the field is pointing up. Field pointing up, remember magnetic field always goes from north to south, so I know that the top is the south pole, the south magnetic pole. So that's what we needed to know. Okay, now if we know that the distance, so the distances between these two faces, well, let me make this drawing better. The faces are here. No, it's one face is here. This is the north face, and the top is south. Okay. So, and we know that if the pole faces have diameter of a certain value, we want to estimate the current in the wire once they give us the magnetic field. Okay. So they give us the whole length of these poles, right? So we will know then what is the whole piece of the wire that is within this magnetic field. Okay, so this is important information because this gives us L. Okay, so to find the current, what do we need? Well, they gave us already the force. We know the force is I, L, B. This is the maximum force, so we know that the current and the field are perpendicular, so that's why I'm not putting any angle there. And from this equation now we can find the current. Okay, so this is part B. So part A was to find out there was south, part B is to give us the current, and then comes part C. Part C says the following: if the wire is tipped so that it makes an angle of 10 degrees with the horizontal. Okay, so what we are going to do here, this was the horizontal direction. Okay, so now I tip my wire a little bit, so this is now 10 degrees with the original horizontal direction. Okay, and remember, here is the south pole and here is the north pole. Okay, so we have this magnetic field here, from north to south. So now there is an angle. The angle is not 90 degrees anymore, it's different from 90 degrees. And what is this angle? This amount here, okay? The angle between the current and the field, okay? So this is the field and this is the current. So the angle between them is not 10 degrees, careful, but 90 degrees, okay? In this case. So this is what you're going to need to use now to get the new force. And what is going to be the new force? Well, the current that you found in part B, the length that we have is still the same, all that part is still within the field. The field that is also given to us, but now careful, we have to put not sine sorry, I made a mistake here. This is 80, right? Not sine of 90 degrees, but sine of 80 degrees, because our wire now was a little bit tipped. Okay, so careful here, I made a mistake. I meant to say 80 degrees because this is the whole 90 degrees minus 10.